Okay, today we're going to talk about complex numbers. Complex numbers have a real and an imaginary part. This is the real part, A is the real part, and this is the imaginary part because it's with our I. This is how we typically write them. This is the form we usually see them in. And in this section, in 9-1, what we're mainly doing is just how to do certain operations with them. So really quickly, if I have a problem like this, and I want to add it to another complex number like this, all I have to remember is that I need to add and subtract things that are alike. So I can rewrite this whole thing without any parentheses. 5 plus 3i plus 7 minus 4i. I'm going to combine my real numbers to get 12, and I'm going to combine my imaginary numbers, 3i plus negative 4i, to get minus 1i. Or you could write that 12 minus 1i. Or you got 12 minus I. Those would all be the same thing. And that's all there is to adding. Subtracting is not much harder, but there's a couple things to remember. When you have the situation of this minus sign, subtracting this whole, oh, that's messy, that whole parentheses, if I rewrite this without parentheses, over here I would write 2 minus I square root of 3. This minus has to be distributed to everything inside this parentheses, so it's going to be minus 5 minus I square root of 3. Now I can combine my real numbers. 2 and negative 5 is negative 3. And I have a negative I square root of 3 and a negative I square root of 3. So I would now have negative 2i square root of 3. Multiplying, this should look a little familiar to you from Algebra 2, maybe Algebra 1. What we have here is essentially two binomials. So we have to use the FOIL method to multiply them together. So I'm going to multiply my first, 5 and 7, that gives me 35. My outer terms, 5 times negative 4i is negative 20i. My inner terms, 7 times 3i is plus 1i. And my last terms, 3i and negative 4i, gives me negative 12i. And I squared. Sorry. What's a little different than what you used to do in Algebra 2 is that we know a few more things about I and I squared now. So this, 35, negative 20i plus 20i is plus 1i. And I have negative 12, and I have I squared. Well, in the beginning of this chapter, we talked about the quantities of I to different powers. And I squared is really worth negative 1. So that makes this value, negative 12 times negative 1, is really 12. If I just bring everything down, now I can combine these. These are now both real numbers. So I have 47 plus 1i. All right, we saved the best for last. Dividing complex numbers. 5 plus 3i over divided by 7 minus 4i. Basically, having a complex number in the denominator of a fraction is just like having a radical. We can't do it. So if that was a radical, we would have to multiply times something that was equal to it to rationalize the radical. Well, we have to rationalize this complex number. And to do that, we use what's called the conjugate. And basically what that is the opposite sign of the same problem. So for 7 minus 4i, the conjugate is 7 plus 4i. So we're going to multiply that times the conjugate, and whatever we have to do the top. And then we're just going to multiply across using the FOIL method that we just saw in multiplying these. And we get 35 plus 21i plus 20i plus 12i squared over 49 minus 16i squared. Because if you notice, what we have here is a difference of squares. So if you think back to Algebra 2 days, we have we're going to end up with a difference of squares here. No middle term. It's going to cancel out. So I'm going to come down this way. This I squared is going to become negative 1. So this is 35 plus 41i plus negative 12 over 49. And this also becomes negative 1. So negative 16 times negative 1 becomes positive 16. And this will become 23 plus 41i over 65. And this also can be written 23 over 65 plus 41i over 65. All I did was separate. These made their own fractions, and this made their own fractions.